Okay, Lexi, we're going to look at another proof together here. This is coming from lesson 57, number 24. I did reset it in your teaching textbooks, the grade book there. I did reset it, so you can go ahead and work through this if you like. Again, I kind of like it if you can watch me work through this, and then if you want to just write down the steps afterward, that would be great. I think that if you can follow me as we go through it, it's a little bit easier to understand as you see the parts happening. Okay, so here's what we've got. We have a rhombus. Remember, a special thing about a rhombus is a parallelogram because opposite sides are parallel to each other. In a parallelogram, opposite sides are also congruent to each other. The interesting thing and special thing about a rhombus, though, it's a special kind of a parallelogram because all four sides are equal. I'm going to go ahead and mark that up. All four sides are equal. We are trying to prove that angle 1 and angle 2 are congruent. Actually, I don't want to mark that just yet. We're trying to prove that angle 1 and angle 2 are congruent to each other, and angle 3 and angle 4 are congruent to each other. So I see here that we've got two triangles that are created with that diagonal inside the rhombus. So we're probably going to try to prove two congruent triangles first, and then when we do that, we're going to see how this turns out at the end. So I guess what I want us to think about here is that in order to show angle 1 congruent to angle 2, we have to prove that this diagonal is actually bisecting the angle at A and the angle at C. Because remember, a bisector will divide it in half. So let's go ahead and work through this proof. So the first thing we're going to do is we're going to write down the given information. Then that is simply that we have a rhombus whose name is ABCD. Because it is a special kind of a parallelogram, a rhombus has four equal sides. That actually comes out of the definition of a rhombus. If you look on page 762 in that packet that I gave to you, I'm looking here, definition 47. Says that all four sides of a rhombus are congruent. Well, I only want to write down the opposite sides to be congruent with each other, so we're going to write down that AD and CB are congruent, and AB and DC are congruent. And the reason we want to write it this way is because, again, we're trying to show congruent parts of triangles congruent. So I'm going to erase what I have done here so that I can mark up some sides. So AD and CB, and then I'm going to put two tick marks on the other two just because I want to show these corresponding parts in these two different triangles congruent to each other. Angle D and angle B are also congruent to each other. I'll put 3 little tick marks on these little angles. And the reason for that is that in Theorem 35, again, if you check your little packet there, it says if a quadrilateral is a parallelogram, then both pairs of opposite angles are congruent. So we're just going to write here that both pairs of opposite angles, that's the symbol for an angle, of a parallelogram, and in this case, the rhombus, okay, are congruent. Okay, now if you notice, we have 3 parts, and that's all we need in our shortcuts, remember, to prove triangles congruent. So here's what we have. We have a side, angle, side, side, angle, side. So that's how we've proven these two triangles to be congruent. So we're going to go ahead and write down the triangles' names. ADC and ABC are congruent to each other because of the side, angle, side shortcut. Now, since that's the case, we know that all corresponding parts in those triangles are going to be congruent. So if that's the case, then angle 1 and angle 2 are congruent to each other, and angle 3 and angle 4 are also congruent to each other. Okay, also, let me just kind of go back and say one thing here. I want to make sure that you grasp one thing. Okay, so remember all four sides are congruent. So that means I'm going to mark these up in, I want to do something here so you can kind of see something. Okay, remember all four sides are congruent. So even AD and DC are congruent. Notice that this triangle now, right here, this triangle has two sides that are congruent to each other. So that's an isosceles triangle. And remember, the base angles then are also congruent. So even 1 and 3 are congruent to each other. And so the corresponding parts in the other triangle, 2 and 4, would be congruent to each other as well. But remember, corresponding parts between those two different triangles are also congruent. So 1 and 2 would be congruent, and 3 and 4 would be congruent. And that is what we were trying to prove. Why? Because of corresponding parts of congruent triangles are also congruent. And that leads us to Theorem 45, which we'll be using in future lessons now, the understanding of that. What this has proven then, and we can use this theorem, says the diagonals of a rhombus bisect the angles at the vertices which they join. So 1 and 2 are joined angles at angle A, okay, and that diagonal is in fact bisecting that. So anytime you have a rhombus, okay, what this means is anytime you have a rhombus, those diagonals are bisecting, creating congruent angles. Okay, and that, my dear, is proof number 24 from lesson 57. Thanks for watching.